All right, folks, I promise this video will be shorter than the last one. Whew, that one took a while to make. Anyways, let's go ahead and take a look at today's lesson. We have 5 word problems, and then we also got a chance for some bonus. So here's what I'm going to do. The other day we talked about the format when we're looking at all of these story problems concerning the absolute values. So I'm just going to write this out so you can use it. The absolute value story problem format, this is going to be the midpoint or the middle value. So I'll put the middle value. And then you'll have a symbol here, so I'll just erase that. You'll have a symbol, greater than, less than, okay? Greater than or equal to, less than or equal to. In fact, I'm going to tell you right now, it's always going to be less than or equal to, okay? So that'll help you out on all these. And then this last one is the range, okay? The range of possible values. So I'm going to look at one of these problems with you guys, and I'm going to let you try some of the other ones on your own. So you got 4 problems for homework tonight. Starting with the statistics, the most familiar statistical measure is the arithmetic mean or average. A second important statistical measure is the standard deviation, which is a measure of how far the individual scores deviate from the mean. For example, in a recent year, the mean score on the mathematics section of the SAT test was 515. The standard deviation was 114. This means that people within 1 deviation of the mean of the SAT math score are no more than 114 points higher or 114 points lower than the mean. So what this means, just to give you a picture, most of these scores are going to come in the shape of what's called a bell curve, okay? And so the mean, the average score, comes right in here. And most of us are going to score, you know, if you end up taking statistics, you'll know more about this, but are going to score somewhere between here and here, okay? This is where most of them will lie. And if you are 2 standard deviations away, you're either outstanding. I think that actually 1 standard deviation is more like out in here. And so if you are 2 standard deviations away, you are borderline brilliant or borderline brain dead over here. Okay? So as we take a look at this, write an absolute value inequality to find the range of SAT mathematics test scores within 1 standard deviation of the mean. Okay? Well, the middle value, remember the mean value was given to us, right? It was 515. I just want to check to make sure that's right. Yeah. Okay, the mean score, yep, was 515. So if I go back to my original formula here, that's where that's going to go. Now, the range of possible values was 114, okay? Within 1 standard deviation. So if we read this last part of the sentence, this means that the people within 1 deviation of the mean have SAT math scores that are no more than 114 points higher, that's where the range comes from, and 114 points lower than the mean. So I'm going to go ahead and write this out like this. X minus the middle value is less than or equal to 114 points, okay? So if I go ahead and work this out, minus 515, less than or equal to 114, and, remember it's less than, so it's and, x minus 515 greater than or equal to negative 114, okay? So if I go ahead and add 515 to 114, I end up with 629, okay? And if I add 515 to negative 114, that should be greater than or equal to. Okay, 515 minus 114, 401. 501, 515, yep. So the scores have to be between 401 and 629. Okay, that's the range of possible scores there. some people will bring these together as a compound statement and say something like this. The scores have to be, let's see here. I want to make my symbols right. There we go, okay. X has to be greater than or equal to 401 and less than 629. That's the range of possible scores if you're in one standard deviation. That's where most of us would lie, okay? Now, what is the range of SAT mathematics test scores plus or minus 2 standard deviations from the mean, okay? Now, if I was going to go ahead and do, would this work if we did an OR? On my paper originally, I put down that it was an AND, but I'm going to try something right here. If we're 2 standard deviations away, no, it's going to have to be. Okay. So if we're within, so we are within 2 standard deviations. So how does that change our initial equation? Well, now no longer is my range 114 on both sides of the mean. It's now going to be double that much. So we have 228, okay? And so again, if we work this out, x minus 515 less than or equal to 228, x minus 515 is greater than or equal to negative 228, okay? So if we add that, let's see here, 33, 43, 743. Is that right? Let me think here. Yep, that looks good. And if we add 515 to negative 228, we end up with 287. Okay, so again, the range of possibilities has to be bigger than 287 and less than 743. Okay, those are the possibilities there. All right, I am going to, I'm just trying to think, do I want to show you another one? That's already taken 7 minutes. I'm going to let you guys, maybe I'll try one more. Let's try number 3, okay? In an Olympic archery event, the center of the target is exactly 130, scoot you back a bit, 130 centimeters off the ground. To get the highest score of 10 points, an archer must shoot an arrow no further than 3.05 centimeters, which is a little more than an inch. Isn't that crazy? It's like 1 1/3 of an inch from the exact center of the target. Write an absolute value inequality to represent the possible distances d from the ground. An archer can hit the target and still score 10 points. So here's what I want you to see. You have this point that is 130 inches off the ground. 130 centimeters. Okay? Around that point, itty bitty space. Okay? The range that you're allowed to be off is 3.05 centimeters. Okay? I know that's kind of hard to see. I'll zoom in. I'm not sure that that was much better. Okay? So this space right there from the center, the deviation is going to be 3.05 centimeters. So from here, as we look back at our problem here, write an absolute value inequality to represent the possible distances d from the ground. An archer can hit the target and still score 10 points. I'm going to do something like this. X minus, I'm 130 centimeters off the ground. So I'm going to put down 130. And the range of possible values here is going to be less than or equal to 3.05 centimeters. Okay? We're going to deviate that far from 130. So if I write this down, x minus 130 is less than or equal to 3.05. If I add 130 to that, I have x is less than or equal to 133.05 centimeters, okay? If I go ahead and do x minus, let's see here, 130 is greater than or equal to negative 3.05. If I add 130 to that, I have 126.95. Okay, and so the range of possible distances off the ground from the top of that circle to the bottom of the circle, okay, is going to have to be between 126.95 and 133.05, okay? So again, I said that we could go ahead and write it out like this if you wanted to. 26.95 and then 133.05, okay? So it says graph the solutions to the inequality. I wrote 133.05, basically 133, 126.95, basically 127, and everything in between. Okay? Now, if some of you are thinking to yourself, you know, I could have figured out both of those basically without using the inequalities, that's great, okay? But remember, we want to practice these because down the road, things may get more complicated, and we want to make sure that we know how to use those formulas. So just something to think about. Let's go on to the back side now, okay? And here's the bonus. It says this: solve the inequalities in color in the integers that are defined by the inequalities to reveal a mathematical symbol in the grid below, okay? So I'll actually do maybe number 7, one of these harder problems as I clear that. So let's look at number 7. I'll write it off the side over here. Number 7, okay? Negative 22 is less than 3x plus 2, which is less than negative 10, okay? Now, as I look here, if I want to solve for x, I have to subtract 2 from all sides of the inequality. So I've subtracted it from the inside. Now I have to do it from the left side and the right side. So this is going to give me negative 24 is less than 3x, which is less than negative 12. If I go ahead and divide everything by 3 to get x by itself, I get x is greater than negative 8 and less than negative 4. Okay, again, greater than negative 8. If you want to switch this, you end up having this right here. Okay, x is greater than negative 8 and x is less than negative 4. So that's the range. If I wanted to graph this out, I'm at negative 8, negative 4. I am not including those two and everything in between, okay? So as I look up here, I have to go through all of these and ask myself what numbers would be between those. Negative 5, negative 6, negative 7, okay? So as I look at this, negative 5, negative 6, negative 7, no. Negative 5, got it. I'm going to color it in. That is one of the problems, or the answers there. Negative 6, got it. Okay. Negative 7. Okay, now you may have to go back and double check yourself a couple times. In fact, maybe you want to go up and down a different direction next time, but you want to make sure that you get all those boxes colored in. Otherwise, it's not going to look very pretty. Anyways, I hope that makes sense. Love to see some of you complete that bonus, see what you can do. So good luck. We'll talk to you later. Bye.